Speaking of reliability, a podcast with good friends talking with you about reliability engineering topics. Welcome to Speaking of Reliability. This is Fred Schenkelberg.
And this is Greg Hutchins. For a second, I forgot my name, but that's welcome to a Thursday morning.
Yeah, there we go. Well, Greg, we've chatted, I don't know how many different things over the years. And I mean, before we got started, we were just catching up, and I was talking about, some CSS code that I'm trying to get installed on the site, and it's got conflicts with existing code and back and forth, and I'm diving into the details of that. But I also was thinking that, and I told you about this when we were chatting, is that the local power company and the local internet company that we use both sent us notices earlier this week that next week on Wednesday, both for whatever reason picked Wednesday, they're going to shut off power and internet access for our local region because they're installing new equipment or doing whatever they're doing. And well, that's just a motivation to go for a walk in the woods that day. I think we'll just plan on doing nothing that day. Yet I know from working at home is that I have a whole house generator installed because where I live, we routinely get power outages, tree branches falling in storms, and then the power system will shut down if there's very high fire danger, and it's all preventative so that they don't spark a fire. So a lot of people have generators, and we have one. Yet I have to service it every year. It's changing oil and checking some timing and a bunch of other stuff on it, make sure it's still working. It's another big piece of equipment. It's another asset in my home system. But when I lose both power and internet, I think I have a backup, but I can use my phone, tether my phone to my computers. But the system is pretty degraded at that point. I'm not going to do a webinar that day, kind of thing. And I could add more levels of redundancy, and I could add satellite cable, satellite internet service, or all kinds of other stuff. But at each step of the way, it adds another level of complexity and cost and failure points and stuff like that. I think there's plenty of engineers, and I've run into plenty of them, that tend to overcomplicate their designs and make it just horrible. Others go to an amazing degree to do redundancy and backups and fix, and it says, well, how often is this system actually used? Oh, it's used one shift a day. Could you do the repairs and maintenance and stuff on the second shift? And then you don't have to create a bunch of hot swappable components in this thing while it's in production, and just, make a system that works for 8 hours, and then you can repair it and fix it and maintain it. Oh, no, we never thought of that. I'm like, okay. And they got rid of like half the BOM of stuff that they didn't need then, and made their system way simpler. The idea here is that a reliable product, one that you will start and turn on and get you to the office on time and stuff like that, or like us with all of our computers and networking and everything else so we can record this thing. At some point, simpler is better. And oftentimes, I should say, simpler is better.
But we don't design for lean. We don't, well, I'll rephrase that.
Some people do.
Some people do, yeah. Boy, this is an interesting thing, because every one of these systems has two components to it. The technical component, where the engineers will over-design or complexify the product, and it's got a social component, which is the user. And, from the user, they want simplicity. They want to flip the switch or toggle the switch and basically get light or whatever it does. But we as engineers, and I'm sort of guilty of that as anyone, I want to add features. I want to add complexity. I mean, I think I've shared in these podcasts before, we're designing an app. Well, the app went from a risk analysis app to a risk framework app to a risk compliance app, down to a governance, risk, and compliance app, meaning a GRC app.
Mm-hmm.
And, the question is, how many users are going to use it? What are they going to pay for it? And are they going to pay for the added functionality?
Yep.
In the meantime, the user, which is a social element of the system, they just simply want a quick fix or a product that's running, or in our case, a low-level assurance. It's a big issue.
Well, I saw an article. I think it was Wall Street Journal the other day. Is there home automation fatigue? For a while, adding the smart little bots or boxes in your house that can control lights or control your faucet or control your oven or pick up, like a lot of the there's a whole series of doorbells and outdoor security cameras that then alert you via your phone with a video feed that the mailman's there or whatever. Smart locks. There's all kinds of cool gadgets for homes, and industry factories have been doing this for decades. The Internet of Things fad or trend, where they're adding extra sensors and extra components and measures and toggles and all kinds of stuff, to the point where half of the cost of the equipment is all the sensors that tell you it doesn't work. And then the sensors fail. And I'm working with a team on escalators, and they have a whole raft of sensors built into the escalators so that it'll detect a dangerous situation. So if your foot gets caught in the grid, it'll pick up on that little flap that's on the landing spot where you get off the walkway onto the floor. Mm-hmm. If that is pulled up a little bit, it'll immediately stop the escalator because there's something caught in it. And it could be a piece of clothing or your shoe, or flip-flops are notorious for getting caught in that, by the way. Don't wear flip-flops on an escalator. But there's also, I think the ones I was working with had on the order of like 20 other sensors. And sensors aren't perfect, and they're in a very dirty environment. And so they get false readings and they shut down the system. They're designed so that they fail safe. If they're not working, they shut down the system, kind of thing, which makes sense. Yet half of the calls were to clean sensors, and so I don't know if it's overly complicated. And when it comes to safety stuff, I fully understand the need to do it. Yet I don't need an overfill sensor on my coffee pot that gives me a text message. There will be water or coffee on the countertop, and I'll know that it's overfilled anyway. So I don't need a sensor that tells me that. It's kind of where I'm going with this, is that some of the things we put together and design and build systems get overcomplicated. And I think part of it is what you're talking about, is that here's the set of features, and I want to make sure I have enough features to get a good enough size user base, because not everybody wants to use it the same way. So I need to add these extra elements to it.
So maybe the question is maybe not so much additional features as what's the scale and what's the impact of the risk. So essentially, let's take the point of view of management in a utility. California PUC Commission, Public Utility Commission, did not give the utilities there, public utilities, enough monies for capital investment. This happened for years. So what happens is the utilities, the Public Utility Commission in California, and by the way, in every state, train the utilities to basically not care about vegetation management, not care about capital investment in infrastructure. So the public policy people train the utilities. The utilities basically said, I don't give a shit. or I don't care, right? Because I'm not going to reap any, what do you want to call it? I'm not going to get any monies for the investment I'm making. So that was the basic approach to the utilities. So they became risk not caring.
Well, pretty much until they had, natural gas pipelines explode because of poor maintenance and starting major fires that wipe out towns
Like
because
Paradise.
of poor maintenance of setting, failures of their high transmission lines.
But these were failures for a product that had a 40-year life.
And they were past that.
And the shackle that broke, had been used for over 100 years or almost 100 years.
Yeah.
So what happens is, especially for public safety or major infrastructure, utilities were trained by the public, by the government officials. So now basically they've overreacted and they're simply shutting down large parts of California, Oregon, and other states, right? To basically they're not only risk aware now, but they're risk.
They're pretty aggressive of prevention.
Oh, it's all prevention, exactly.
Yeah, no, and it's a lot less expensive to prevent a fire than it is to pay for it afterwards, especially if you're at fault.
Yeah, well, what's fault? Is the original fault the public utilities not approving capital investment?
Well, they don't improve capital investment. They never have. They do the rate structure. And it's up to the utility to say, we need a rate structure that allows us to do that without compromising our profit. So instead they chose profit. I look at it, maybe I'm too progressive or something, but if PG&E has been making billions of dollars and giving dividends to their shareholders for decades and decades, instead of maintaining their systems, they are extremely rich until recently, because they got sued and said, no, you need to spend $1 billion fixing stuff. And the issue is they have $1 billion to spend on it, but they chose not to.
Utilities get money from two sources. One is the investors, and the second is the ratepayers. And in terms of the ratepayers, the Public Utility Commission sets the rates.
Yeah.
So who's at fault? The Public Utility Commission that didn't improve the capital investment? Or is it the utility, the operator, who basically is at fault? By the way, this same issue that we're discussing here is the big issue for California and AI. Who's at fault? Is it the developer of the AI system?
Oh, you could go with the social media platforms too. It's
the same. It's the same
basic logic. Yeah,
it's the same basic logic.
There's plenty of fault to go around, and there's whether or not there's guardrails or not. It's some parts of our systems just lead to the results we get, and I look at it as it's not this or them. It's the system that we're playing the game in. If you want deferred maintenance, well, then you set up a system that allows you to easily defer maintenance.
That's right, because utilities design for failure. They don't design for reliability. It's a very important concept.
Yeah.
You, as a professional in reliability, say the system should be reliable. Great. What is reliability? How do you define it?
I could spend a whole lot. I could spend about 2 minutes telling you, but it in a large system, it gets more complicated pretty quick.
In a large system, you have both sides. You have the social policy, the public policy side, and you have the technical systems. And what happens is that the engineers are functionally focused, and the larger issue of the social system, and again, we're talking about nuclear power now, we're talking about electricity, we're talking about communications. All these systems now have social components where public policy is trying to react, after the fact, right?
Yeah.
And is having a very hard time with it.
Yeah. No, and it's usually not a good place to be at. Now, one of the things when I'm thinking about the overcomplication of our various systems, and there's so many factors at play that make it go this way or the other way. And I think the social element of it is a piece of that. But right now we're using our individual computers, and they could be essentially any PC or any Mac, any Linux system. I mean, we could be using all kinds of different platforms in our individual offices that we're using to connect. And then we have, I think my system right now is using Wi-Fi to a router to a telephone pole out on the street that goes off to servers, and somewhere along the line, it connects to whatever service provider you're using, to your modem, to your Wi-Fi or cable, to your particular computer. And there's various standards for all these different interconnects that are set up so that they actually pass packets appropriately. And then on top of that, we're using Skype right now, but we could be using Zoom or any of a dozen other or software packages to connect and record this audio in a way that we can actually use it for a podcast. And all of those things work. The complexity there comes into the stack. What setup do you want to use? And both of us, you and I both have made different decisions about what computers or what internet provider we're using, what systems we're using. Me being a reliability person has backups for various elements of my system. Of course, some are better than others, but the idea is that when you look at it as a system, it's an amazingly complex setup. Yet it has this interoperability that allows you and I to make different decisions, and it still works.
And my point is, engineers design for the product. They don't see the larger picture of the social consequences or even understand the language of risk. And that's the problem and again, I'm an engineer, I'm a professional engineer, mechanical. We tend to be so limited, almost blindfolded, with our focus on the product that the larger issues we forget about. So the question I would pose is, when these systems fail, and they'll fail very quickly, and they'll cascade and they'll go sideways.
Yeah.
Who pays for it?
Yeah. I think part of what made me think of this topic is that, one, we wouldn't be able to do this podcast without this incredibly complex system actually working. And yet, from my point of view, it's pretty simple. We both get a bunch of choices to make, and we can make it work. Now, the electrical system, and this note I got that the electrical and the local internet are going to be shut down for scheduled maintenance. It's nice they let us know. That's okay. It doesn't, working from home makes it a more of a challenging day. But we can prepare and do stuff about it. The issue is that 25, 30 years ago, if the power went out, one, I probably wasn't going to be working at home. Two, the only thing I'd worry about is, my freezer, just remember not to open it so that it keep the food cold. And if it goes on too long, go get some ice. That would be about as complicated a day as it would get for me. Whereas today, it means I can't remotely turn my hot water heater on so it recirculates to get hot water to the shower. My sound, like the lights in my studio, are voice activated. There's no switch for them. It cost me $20 to put a smart speaker in the room and buy, a Hue light bulbs that I can remotely control. Then rewiring this room, which the electrician said would cost about $10,000. And I'm like, well, I'm not going to spend $10K when I can spend, 40 and solve the problem. He said, that thinking's bad for my business. Well, tough. Yet it set me up as being vulnerable to power outages and internet outages, because the voice command thing doesn't work if there's no internet. And I don't have a backup to connect all of the voice command stuff in the house to my phone, tether it to the phone. I don't have a way to do the whole system on that. So adding extra layers of complexity, from my point of view as an engineer, adds more points that it could fail as a reliability engineer. From a business point of view, there's all kinds of trade-offs. And some of these systems are so complicated. Like the voice activated lights in my house means that I have to leave if it's connected to a light switch, I leave the light switch on so they're powered so that they can turn on and off with voice activation, voice systems. And at first, anytime there was a power outage, all the lights would come back on. And I was like, oh, that's a pain in the butt. And they finally figured out a way that they'll come back to the state they were before the outage. And some software thing they did said, all right, we were off, so when the power comes back, we'll stay off, kind of thing. And vice versa. If it was on, it would come back on. But the issue they had was with fire departments. When you come into a home, one of the things they'll do, if there's power still to the house, they'll turn the lights on, but the switch is already on. And they're not going to figure out the voice command because you can make it whatever you want. So they finally made it so that if somebody comes in and they flip the switch off and then on twice pretty quickly, the lights will come on, even though they're voice commanded lights. And so they sorted out a safety issue that was the habits of a long time existing systems ever since we had electric lights, is that they would turn the lights on as part of their process of entering a building under certain circumstances, I'm sure. But that was disabled because of this added complexity of having voice commands to do your lights or programming to control your lights. That's what I mean by the overcomplication of things. It adds a layer of convenience, and it's kind of cool. And it actually is nice to have some of our lights are set up strictly on schedules. They come on at dusk and turn off, sometime later, or a handful of the routines that we always do in the house that we just automate them. Things like that is pretty nice. Yet it adds a layer of complexity and more points of failure. And it's in this article I was mentioned a bit ago, is that when the power goes out or when something stops working, it's not as simple as just go change a light bulb. It's, you got to dig into, well, what part of the system is not working? And then go fix that part. And it might be a router reset. It might be a loss of communication because you put some barrier in the way. It might be all kinds of different things that go on, but it's now a networking issue as much as it is a burnt out light bulb. And my wife is, when the internet's not working for whatever reason, at least she knows to go restart the modem and restart the router. And yeah, that sometimes clears it, but sometimes it doesn't. And then you're like, now what do I do? And says, well, that kind of depends. She doesn't like that.
That's right, because now we have to problem solve. So what's the solution? Most engineers are trained to look at the product and to add complexity, because this is the way they think. Simplicity, meaning, building a Zenny product, is a different skill set that we're not trained in school. So,
well, I know there are exceptions though. There's things like Lego bricks. Right? They haven't really added new features. They've added some new styles of bricks, and they've bought trademarks into different popular books and movies and stuff to make, sets based on that. But a 2x3 block is still a 2-3x3 block, and it fits the blocks from 10, 20 years ago just fine. And they take great pains and really brilliant engineering to make that work. The idea, I think, is, and I've run into engineers that really are brilliant in the simplification of stuff. And I think I've told you this story before, is this mechanical engineer for a circuit board we had a really inexpensive connector on the board. And the problem is that during the soldering process, it would float and would get unaligned, and it would raise up above the circuit board. And now you have these little flimsy leads overly exposed, or in some cases not even connected anymore, because it would float one end of it up real high and it wouldn't even connect. So you had to rework it, and those generally weren't useful connections for reliability and all kinds of other reasons. Cause more damage than benefit. And so the U.S. mechanical engineers created a very expensive tray with cams and gears and weights and all kinds of stuff. And it took you about 1.5 minutes to connect your circuit board to it and do all the settings. And then it would go through the wave soldering. And they figured that you would have to replace that tray, throw away that tray and get a new one in place after every 5 trips. And each tray they made was about $200 to hold down 2 connectors.
Ouch.
and we're making thousands of these a day. And it was so that we needed hundreds of thousands of dollars to make these circuit boards. And so I reluctantly got one shipped to us that this guy built, and we were going to give it a try. And the engineers on the line at this production plant they went, let me try something tomorrow. I'll come back tomorrow with another idea. And they basically like, get that out of here. That is not going to work. It would take extra personnel. It was very expensive. All these other problems with it. Time consuming too. And all of those features were not thought of by that U.S. engineer that put this together. And so this guy comes back the next day and he had a satchel full of what looked like bean bags. And they were a little bit bigger than the connector. And they were made with a high temperature resistant material. And they had ceramic pellets inside them to give it weight. Think like pie weights in a little bean bag thing. And he said, here's the board. You put the connector gets placed on it and you put a bag over the top of it. And they cost about 3 cents each to make at volume. And he had 50 of them made overnight. Right. And we did production that day and they worked beautifully. Not a single connector was poorly soldered or misaligned. And they had a bag full of these things. They'd put them on the boards and they go through the wave solder and then they come off the board and somebody was already there taking a look at the boards, making sure they got soldered correctly, and they'd take the bags off. And when you ran out of ones to put in, you went and got the other bag, switched out the 2 bins. It worked beautifully. It was cheap. And those bags, they're probably still working. And like, that's elegant. That's actually understanding the problem. And it's more in the larger context of, well, how do we adopt this in the plant? How do we not affect throughput time and quality and all the other benefits and things like that? Yeah, it's way fun making a gears and cams and a big tray like this thing, but you kind of missed all the other features it has to actually be useful.
Yes. So we've talked about a lot of stuff. I would agree being lean, elegant, and simple and zenny works.
Zenny. Well, it does. It really does. And so I guess the message in this one is, think about what the real problem is you're trying to solve and come up with that simple, elegant solution. Yes, it may be more difficult to do. You have to think. But it's also including, as you're mentioning, Greg, the user interface and the social aspects of it and all of the business factors that go into it. All of those things matter in a design, in a solution of any kind. And so it's a challenge. I also find, and I'll ask our listeners if they agree, is that usually the simple, elegant designs, even though they may be a challenge to create, to come up with, tend to be more reliable. Not always. The old light bulb with a 120 volt electric power to it with a switch, a mechanical switch, actually is really simple and it works. It's worked for decades and decades and decades. Adding the complexity of another layer of controls on that thing just adds more points for failure and frustration and more. For me, it's fun for troubleshooting, but that's just me. So what do you think? If you're listening to this, have you run into good examples of overcomplication, and becoming dependent on systems that, that really hurt if you don't have them, if you're not able to turn the lights on or connect to the internet for a day. Those kinds of things. It's not necessarily overcomplication, but it's our interdependence on all these different systems. So let us know. Head over to accendoreliability.com/go/SOR. You can find a couple of ways to get in touch with us. Greg and I and the other hosts of the show are available through LinkedIn and our About pages on the site. And as always, we look forward to hearing your comments and stuff as we're working on our next thousands shows. What is it, Greg? Like 13, 14 episodes ago, we did the 1,000th episode.
Yep.
And so we're well on our way. I think this one's going to be number 1014. So we're chipping away at the next 1,000. Maybe we should do a 100 milestone again.
Hey, I'm here.
Okay.
Got me in.
All right. Well, thanks, Greg. Talk to you again soon.
Take care, everybody. It was a good one. Bye-bye now.
Thanks for listening to Speaking of Reliability. We invite you to join the conversation. If you have a question or a topic that you think we should discuss in a future show, please let us know. You can find a comment box below the episode show notes, or just leave a note as part of a review on iTunes.